Hello everyone and welcome to Module 7 of this training course on the Internet of Things for hydrologic measurements. My name is Douglas Nyole. This module is part of a series of modules that have been prepared for this training course. In this module, we will be covering two important concepts required in an IoT system: the keeping time concept and the Deepsleep concept. We will start with the keeping time concept. In any IoT system, time is very important. That's why for IoT systems for hydrologic measurements, we have to pay attention to time and set it at the beginning. Advanced electronics such as a laptop or mobile phones, that is the smartphones, usually keep time continuously. Therefore, whenever you switch it on or off, it's always keeping time. This is because they have a backup battery installed within it that powers the real-time clock. Unfortunately, the LoP4 microcontroller doesn't have a backup battery to power the real-time clock. Therefore, whenever we power it off, it loses time. And when you power it on, the first thing you need to do is to set up the time. Normally, when you connect power to a LoP4 microcontroller, the time that will be displayed is a Unix time, which is on 1st January 1970. Therefore, you have to set to the current time before you can set up your IoT system. While the LoP4 microcontroller is powered, the real-time clock is what will be keeping time as the IoT system is operating. Once the LoP4 microcontroller has been powered, the first thing we need to do is to access the real-time clock. This is possible by using the machine.rtc function. Once we access these functions, that is the RTC function, we will then go ahead and set the time. Here, we display a script that is used to access the real-time clock function and to set the time. In the first line, we import the module, that is the RTC module. Then, we set a variable for that function in the second line. In the third line, we are able to print the time. And because we have not set the time that will be displayed is a Unix time, that is 1st January 1970. In the fourth line, this is where we are able to set the time. Therefore, we use the rtc.init to set the time by providing the year, the month, the date, hour, and minute in that order. Therefore, pay attention to enter the correct time by checking on your laptop time or your watch and be able to enter the details as presented. Finally, we use the last line to print the time, and it should be able to display the time that you have provided, which should match your laptop or your watch. We will now go ahead and cover the Deepsleep concept. The Deepsleep concept is designed to save on battery charge, that is. Therefore, when your IoT system is deployed out in the field and is powered by a LoP battery, you may need to save on charge in that battery so that your IoT system is able to run longer. Therefore, the microcontroller is programmed to sleep when no measurements are being taken. It will then wake up or start to take and process measurements before it goes back to sleep. This concept saves a lot of battery power because power is only used when the system is taking measurements. The rest of the time when it's asleep, it's not using any power. Therefore, your LoP battery is able to last longer and you don't need to go and replace it. The microcontroller is able to wake up or start through two approaches. The first one is on a fixed time interval set on the microcontroller, while the other one is through the action of an interruption. To implement these approaches, especially the first one, that is fixed time interval, the LoP4 must use a real-time clock to keep time. In the fixed time interval set of the microcontroller, the approach is applied for variables that are continuous in nature, such as temperature measurements, humidity, water flow, and many others. Therefore, measurements are only required at a specific time interval. The time interval could be set to 30 minutes, 1 hour, 2 hours daily, depending on your temporal data needs. In this slide, we display an example of a script used to implement the fixed time interval to be set on the microcontroller. So we start by importing the necessary modules, we then set the time, and then we give the instructions on what actions to be taken once the microcontroller wakes up. So we define the pin that is used to wake up. Then the system is able to wake up using the instructions defined. And once the action has been taken, that is taking measurements or whatever action is required, the system uses this line of script to go back to sleep. The other approach of the microcontroller waking up is through the action of an interruption. This approach applies for variables that are not continuous in nature, such as precipitation or rainfall, flooding, reservoir or tank water level, and many others. Measurements are only taken when a condition is met, which triggers the system to wake up. That is, sleep is interrupted, and then takes the measurements. This approach is very similar to the action of a push button. Therefore, for example, if your microcontroller is asleep and you observe something, you can easily go to the microcontroller and press the push button for it to wake up and take the measurements. In this slide, we display an example of a script that is used to implement the action of an interruption. Therefore, we have the pins to give the instructions in terms of the LED and the push button. Then the action that is taken once the button has been pressed, which triggers the interrupt. And then this is how the interrupt is implemented. That is used by releasing the button or pressing the button. Now, let's go ahead and perform the two deep sleep approaches. In the first task, we will start with a fixed time interval. Take time to read through the instructions carefully before you start. You may refer to previous slides or previous modules in case something is not clear. For the first task, go ahead and start Visual Studio Code. Then connect the microcontroller to the computer and ensure that it's reading from the right COM port. Now navigate to the folder containing the Deepsleep files. Once you have opened the Deepsleep folder, select the main.py file, which should display the scripts like what you see in the image. Now go ahead and run this script. What do you observe in the terminal? Once you have completed task 1, remember to use a Ctrl+C to stop the script from running. Now go ahead and start task 2, that is action of interruption. Read through the instructions carefully before starting. Once again, if you have any challenges, remember to go to previous slides or previous modules for instructions. In the next videos, we will demonstrate how to do this. Thanks, and that's the end of this module.